So in this lecture today, uh, I'll start wave motion, right? What may be in this lecture, I'll start wave motion. So student, I'll just wait for 5 minutes so that maximum student can connect. Hello, my dear. How are you? Okay. So now I'll start your class here as usual. Okay, very good, Vita. I'm very happy to. Oh, doing great, doing great, my dear. Doing great, my dear. Okay, just wait for at least 2 to 3 minutes so that maximum student can connect. Yes, okay, fine. Yes, beta, just wait for 2 minutes. Okay, so now student, as I say, 2 to 3 minutes. Hare Krishna, student. Beta, your class, I'll start 2 o'clock for next week, my dear. Yes, yes, beta. This is beta wave motion for 11th class. For 12th class student, ray optics, I'll start 2 o'clock once I'll finish this class. Uh, Aditya, student, your class I'll take 2 o'clock, right? Okay. Students, I can say finally time becomes over. So now, student, I'm going to start your class as usual. So, beta, in today class, as I said, I'll start wave motion, right? So, beta, here, just we concentrate everyone on lecture itself now onwards. So, student, now I'm going to start. This is wave motion. What, my dear? Wave motion, or beta, you can also say transverse wave, or beta, you can also say transverse wave, right? So, in wave motion, student, first we'll highlight what is the definition of wave, right, my dear? First, I'll highlight student what is definition of wave, right? So here, beta, for definition of wave, it's literally very easy to say. Uh, Beta, you can say wave. What, my dear? Wave carries energy. Students, you can say wave carries energy. Wave carries what, my dear? Energy. So you can say what? This is the definition of wave. Now, beta, wave is a mode of what? Energy transfer. Beta, another definition you can also write. What is, student? Wave is mode of Wave is wave is mode of energy transfer. Wave is mode of beta energy transfer in which student in which displacement of medium in which beta Z displacement of medium particle displacement of student medium particle is not required. Beta Z not required. Okay, now students, I'm going to connect here types of wave which is mentioned in our syllabus, right? So student, for types of wave, student basically wave you can categorize into part. Student wave you can categorize into part. So what is the first one? Mechanical wave. What my dear? This is the mechanical wave. And second students you can take this is non non-mechanical wave, right here, mechanical wave, and what you can say non-mechanical wave. What is it I can say points which you can remember about mechanical wave and non-mechanical wave. Mechanical wave beta, what you can say, to propagate mechanical wave required medium. This is what my dear required medium, right? To propagate students mechanical wave. What's the requirement? Medium is required. Beta for non-mechanical wave for you can take example of sound, right? What is you can take example of sound, my dear. So you can say for non-mechanical wave, you can say the medium is not required. Students for this condition, you can take medium is not required. Medium is not required. Beta, you can take example as a sun ray. Student, you can take example as a sun ray. Okay, very nice. Now, which there is few points which you can keep in your mind. Uh, Basically, beta, you know, this is arrangement. This is literally highly important. Okay, so this is my idea. You can take this is what radio wave. Then we tell you what you can take. This is MW, what implies microwave. Then students, you can say infrared. Then we tell you visible region, or you can say video, or you can say bacha, this is what video, ultraviolet region. Next students, you can say this is what X-ray, and next we tell you can say gamma ray. This is what my dear gamma ray. Uh, Hello Shubham. Hello Sagar beta. Okay, fine. So now beta, this is what you can say radio wave. This is beta, you can say I arranged. Uh, Hello Dibya beta. This is radio wave beta. Sir can be copy. Shubham, everything beta, you have to make notes. Shubham beta, everything beta, you have to make a note. It's a highly required beta, right? Because we will not get such thing in classroom. Physical classroom, there is a basis to complete syllabus. So beta here, there I'll go little fast, but here I'll go smoothly so that you can understand this topic. You know, wave motion definitely read every at least one questions or two question highly required in JEE mains. One questions minimum, one questions minimum. Okay, so just try to focus in class. So beta, this is as I said already I have written radio wave, microwave, infrared, figure, or I can say visible region, ultraviolet, X-ray, and gamma ray, right? Because here, just understand the things here. Beta, what I can say for these all conditions, beta Z, beta, you can consider yourself last 5 or 8 years, right? You can realize, but I know in the sky, how many birds are flying, right? You can just take for consideration last 5 year or 8 years, how many birds easily they are what flying in the sky. But nowadays we are looking very few. Nowadays we are looking very few because of what? No, everywhere we can connect 98.3, 100.2 like that, right? Because we can easily connect from what I can say through the throughout the satellite. Throughout the satellite, we can easily connect any you can say radio channel, right? Because of what radio wave nowadays increase. Radio wave nowadays increase. Okay, fine. Now students, I can say, so this is a radio wave has a beta maximum wavelength. A radio wave beta what it is maximum wavelength. So now beta this what's the point which you can keep in your mind? Student, if your motion left to right, students, if your motion left to right, then what you can say, my dear? If your motion left to right, then beta what you can say? Wavelength is what would say party? Wavelength is decreases. Students, if your motion left to right, then beta what you can say? Wavelength decreases, right? And beta one more thing you can say, bacha. That is what, my dear? Sir, this is what frequency increases. Frequency increases. Now, beta, if the frequency increases here, then what you can tell bacha ji for this condition? What about, can you comment on energy, beta? Anyone from all of you? If wavelength decreases, frequency increases, can you comment on energy? Energy increases or decreases? Students, can you comment on energy? Energy decreases or increases? Anyone from all of you? Anyone from all of you? Can you comment? Can you write in chat box? Okay, okay, okay. Wavelength decreases. So, my dear Subham, how can you say energy increases? Do you have any mathematical formula to justify your answer? Do you have any mathematical formula, student, to justify your answer? Anyone from all of you? Those who currently watching me, can you answer better? Okay, okay, fine. Now, beta, I'm going to tell you here. Because students, all of you remember here, beta, take snapshot. I wanted to beta change the page. Okay, I hope you have taken. Now, beta, just listen carefully here. What's the point which I wanted to discuss? Student, as I said, wavelength decreases. Now you can see frequency increases because both are reciprocal to each other. So here, which I wanted to add the points there. I can see what is the formula of energy. I never teach you. I never taught you like, but you can use this principle there. This is what, my dear. E is equals to maybe you completed in chemistry. Hc by lambda. What the party? E is equals to Hc by lambda. If beta G E is equals to Hc by lambda here, then what you can say, if you are decreasing wavelength, then you can write what? Energy increases. So wavelength decreases, frequency increases. So what you can say with the energy? Correct, beta, Sagar beta. Now, correct. This is correct, dear. Okay, be concentrate lecture here because I'm looking from both of you at least 100% yeah, score for coming test. Okay, my dear. Now, beta, I can say little basic point here. I wanted to discuss about wave phenomena, right? So, what is a wave and what is a pulse? Yes, beta, we have to understand. Okay, so I hope all of you got it here. Mechanical wave and non-mechanical wave. Mechanical wave and beta, what I can say non-mechanical wave. Beta, further you can just before going to depth study beta Z. I wanted to do something here, right? You can see this is what my dear general physics. What my dear, this is student writing general physics. Okay, you can apply it anywhere. Okay, so Bacha ji, for this condition, Shubham, is it possible to you, beta? Can you follow once here? I can say SS because beta, as I committed different time here, so I don't have also contact. I have, but I need to find if possible for you, beta. Just once, I can just follow beta SS and invite to join the class now only. Now, beta, have a beta talk over there. This is what my dear. Uh, yes, Sagar, you can do beta. Now, beta, general physics here. Yes, beta. Yes, Sumang. So, beta, general physics here. Have a look, everyone. Now, students, you can say this is what basically x-axis. You can say this is the y-axis. Beta, take in consideration in your hand. Students, take in consideration in your hand. Beta, this is one end of a string. You hold it from your hand and you supply energy like this. You supplied what energy like this. If student, if given, if you are performing this experiment or this demonstration, then what you can say, this end is remains fixed. This end is what remains fixed. So which you supplied the energy. Due to this energy, what you can observe there. There is what formation of pulse. But what we can say, there is what formation of pulse. Okay, fine. Formation of pulse. Okay. So bacha ji, for this condition beta, you can take for consideration. Let us suppose you give energy to string. A string you can you are observing this kind of I can say pulse. Okay. So now students for this condition, I hope all of you know basics point of physics here. This is what made you. You can say it's a half circle. Okay, Subhang beta. Good. Good job, beta Subhang. Beta, God bless you for your good job. Now beta for half cycle. What is the time period, my dear? This is what you can see beta. Angle table by particle is what? Pi. Beta for complete circle also. This is what my dear student stabilized. This is what my dear you can say 2 pi. This is what beta you can say 2 pi, right? Okay. So beta have look here. What is the entire things beta party? If beta your wave, students, if your wave traveled one complete cycle, students, if your wave traveled one complete cycle. So this is what here? This is known as students. This is known as wavelength. Beta, what you can see? This is known as wavelength. Okay, fine. But let us suppose you can take into consideration speed of the wave. This is what v. This is what, my dear? This is what you can say V. Okay, fine. Now, Bachaji, this one, what we are calling, anyone can you tell me from your side? What's the name of what's the name, beta, for this one? What's the name of this one, Bacha party? This is what known as crust. This is what, my dear? Crust. Now, beta, this is what you can say trough. This is what, my dear? You can say trough. Okay, so beta. Now, beta, this is crust, beta. This is what? Trough. Okay. So, beta, as I say, let try to just take assumption. Speed of wave is what? V. So, V is to find. V is to find. And this, how much distance travel by the wave in one cycle? That is what? Lambda. So, you can write here, students. That is Speed. Speed is equals to what, beta ji? Lambda by g. Speed is equals to what, beta ji? You can say lambda by t. So now, beta, 1 by time period. What we are calling, beta ji? 1 by time period. Anyone from all of you? This is what you can say frequency. 1 by time period, what you can say, this is what frequency. So you can manipulate with your result here. Speed of wave. Students, you can write speed of wave. It's nothing but lambda into mu. Where this is what made here. This is basically frequency. This is what my dear. You can say frequency. Okay, correct, 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 correct. Very good, my dear. Be active here. Be active, बच्चा. Party. Be focused on class. Literally, you will get very good benefit of this class. Now, bच्चा party. So we used to find lambda here. We used to find wavelength. So how can you find bच्चा party wavelength? Wavelength, beta. Yes, just say बच्चा. This is what you can say wavelength is equals to speed upon bच्चा party frequency. Wavelength, my dear, what you can say, wavelength is equals to speed upon frequency. Beta, why is it in general physics? Beta, ji, behalf of this thing, beta, literally, beta will get here very good. This is you can apply for entire. Either you can apply sound wave, beta, ji, alternating current, EM wave. Sometime beta, I can see also in SSM as well. So this is literally beta. I can see common things. Okay, so beta keep in mind what's about this one. Beta one more point what's about it. Note. I beta everyone just take snapshot. Student, everyone beta take snapshot. Okay, fine. I hope you have taken everyone. Yes, beta. Now there is a point here. One point beta you can note down in notes. With me only beta. Everyone note down with me only. This is note point. Students, what's the point here? You can write frequency student frequency is frequency is independent of medium. What, my dear? Frequency is what? Independent of medium. Okay, fine. Now, beta, as I said here, basically we can define what, my dear, in two part, mechanical and non-mechanical. So, beta, positively or non-mechanical defined, that is beta wave for 12th class. In 11th class, student, we will learn about mechanical wave. What, my dear? Mechanical wave, right? So again, beta, I'm going to just explaining you in detail types of mechanical wave. What was the types of mechanical wave? Okay, yes, beta, you joined a little late, so beta go and watch same video starting 10 to 15 minutes, beta. Okay, mechanical wave. So now, beta, mechanical wave again, beta, defined in two way. My dear, mechanical wave again defined in two ways. Okay, so beta, what you can see, this is basically transverse wave. What which I can see, transverse wave, and this is my dear, you can say longi. So there are many key changes. Okay, then beta, just send me beta paper, Shubham, and beta highlight the questions and beta sharing key also. And what is the in which question beta you are facing like there is a key change or any problem? Okay, then beta just WhatsApp me student. I'll see and back to you, my dear. Okay, now beta we focus on class. Beta mechanical wave defined in beta in two things. This is what the transverse wave, transverse wave beta, and next student this is longitudinal wave. This is what, my dear? Longitudinal wave. Beta, I can say mechanical wave defined in two parts, two waves, and two kinds of wave, transverse wave and beta what you can say longitudinal wave. Okay, so now student, first I'll discuss my dear. This is transverse wave. Okay, fine. So beta, what is transverse wave? Beta, understand here. Let's take for consideration. Take for consideration, student. Yes. So this is basically wave is propagating like this. This is a wave propagating like this. Okay. So now it says, as you know, everyone, this is crust beta. This is the point you can take beta for half cycle. This is the point beta you can take for full cycle. Right. Okay. But Chaji, as again I'm telling you, let us suppose this is what direction of velocity of wave. What beta? Velocity of wave. Okay. Now, Muktazi, after some time, I'll give you like mathematical formula of this wave, my dear. That is what you can say. Uh, this is a student for this condition. Beta for this condition. No, all particles in wave, all particle in wave, what performing accession. So, beta particle literally, student particle literally are. This is the what motion of particle. So particle motion is what beta? This is what perpendicular to wave velocity. Student, particle motion is perpendicular to wave velocity. So this is what you can say about the party. If motion of particle is perpendicular to wave velocity. So beta, this is what known as transverse wave. What you can write it as E, motion of motion of particle is perpendicular. Motion of particle is perpendicular to wave velocity. Is known as what, my dear? Is known as transverse wave. What, my dear, is known as transverse wave. Okay, now let's have a look next beta. That is what, my dear? Longitudinal wave. Since what you can say next one, this is a longitudinal wave. That this is just reverse of this. You can take consideration like this. How students? Again, you can take this is what wave. This is what direction of velocity of wave, right? And whatever for this condition, you can take in consideration. This is what particle velocity. This is what, my dear? Particle velocity. This is what, my dear, you can see particle velocity, right? So beta for this condition, what you can say motion of particle is what along the wave velocity. What students you can write as a definition, uh, students motion of particle, students motion of particle is along motion of particle is along the wave velocity. What is mean? Motion of particle is what? Along the wave velocity. Right, Vacha? Now, this bit I can say literally bit very too much basics points. Now onwards, Vacha, we'll go through this. Right. Basically, beta, we can also take in consideration. So before proceed the things, Vacha, we have to understand what is a pulse and what is the wave. What, my dear? Pulses, pulses and wave, right? So beta, just understand everyone. Pulses, pulses and beta see wave. Water spreads, pulses and wave. Okay. So let's say for this condition, what you can say, students, take as an example. Let us suppose you can take beta. This is the wall. This is what, my dear? Wall, right? This is a wall, my dear. And take in consideration, this I can see from your hand. This end of a string, you in your hand, you hold it. Just you can take. If you hold it, this string. Just now. Okay, Bachaji, I can say next, this is, you can say demonstration. Let us suppose you are performing demonstration and you wanted to understand what is pulses and wave, right? So let us suppose this is hand, I can say I have to make a hand of S. This is SS hand. This is SS hand beta. Okay, SS holded this string, right? Okay, now it's about it. So now S is wanted to what? I can say supply energy. S is wanted to supply energy to this string. Okay, if beta SS wanted to supply energy of this string, bacha, then what you can say? Let us suppose he already applied energy into a string. So SS can find, SS can see there is what? Formation of pulse takes place. What, my dear? Formation of pulse takes place. So one way to demonstrate wave motions, to flick one. One way to demonstrate one way to demonstrate wave motion is to what? Flick. Flick at what? One end of a long string that is under tension and has opposite end fixed. Now, beta, because no one end, beta, this is remains fixed. You can take in consideration. Then you can perform what? I can say beta formation of pulses. Formation of pulses. Okay. So beta, you can ask, sir, what is the exact definition of pulses? So note down with me, everyone here. Everyone note down with me. Definition of pulses. Beta, what you can say? Definition of pulse. Definition of pulse, beta. Okay. Beta, note down breathing everyone. The pulse has students. You can note down with me. The pulse has defined student. The pulse has defined height. The pulse has defined height and a a definite speed, definite speed of propagation, definite speed of propagation along along the medium. What medium? Along the medium. Along the medium. And in bracket, still you can take string. Beta. Base definition already I gave beta. Beginning of this class. Beginning of this class only. Right. So just take in consideration the party. You can also understand more. Let's understand with a more example. Let us suppose, as I said this point here, this is what directions of wave velocity, and this is what directions of particle velocity, bacha. So you can take in consideration like this. Then, bacha, this is I can say about pulse. This is what I can say, bacha, about pulse. Now, beta, types of transverse wave already I discussed, right? So there is one more point, bacha, party. at the surface of water. Note beta, NOT, note everyone. Everyone just make notes of this thing because maybe they can ask student in the paper as a theory question. So what students as the surface of water as the surface of water, बच्चा जी, both waves both waves are present. Both waves are present. Transverse wave as well as both waves are present. Transverse wave, transverse wave as well as longi, longitudinal wave. What is meant? You can say longitudinal wave as well as about transverse wave. Okay. Now with the surface of water, there is only transverse wave, which is the surface of water because both are better. Sound waves in water. These all beta. This is note beta one. Now I'm giving you note number two. These all are beta already question, right? Asked somewhere, right? That's about it. So what you can say. Next one beta. The note down with me everyone. Sound wave. Sound waves in water. Sound waves in water are trans transverse wave. Transverse wave because keep in your mind, I'll ask this all questions tomorrow. I'll ask this question to everyone tomorrow. Sound wave in water are transverse wave because sound waves in water are transverse wave at the surface. Sound wave in water are transverse wave at the surface. Keep in your mind at the surface and 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 longitudinal along depth. Student longitudinal along depth. Yes, beta. Just keep in your mind here, these all things. It's highly required. Beta, it's highly required. I hope done everyone. Okay, fine. Beta, note beta. Just everyone. I hope all of you written beta. Should I change the page? Should I change the page, my dear? I hope all of you written. Okay, that's very good. Yeah. Next one, that's it. Basically, just now beta, we finished. Yeah, I can say second last week. That is what fluids. What student? This is nothing but fluid. So I hope all of you remember. Yeah, fluid. You can say fluid. This is what beta I can say. Liquid, liquids plus gases. No, beta, these two are what? Only longitudinal wave. Beta, what we can say? These two are belongs to student. These two are belongs to longitudinal wave. Beta, what you can say? These two are what belongs to longitudinal wave. Okay, very nice. Now bacha ji, we'll start here, discuss it in detail. Plane progressive wave. Yes, that is I can say bacha for major agenda for today class. Okay, good Shubham beta. Now bacha, plane progressive wave. Plane progressive wave. Today, plane progressive. Plane beta progressive wave. So in short, beta, I can write here PPW, PPW. Okay, okay. So beta what? Plane progressive wave, beta. What you can write? PPW. Okay. Beta, note down with me here everything. First understand here. What is the plane progressive wave? What is the plane progressive wave? Beta, I can take as a consideration. String, you can take as a consideration. Right. So this is string and this is what formation of wave takes place. You can say which about formation of wave takes place. Okay. So which I know this is what known as amplitude. What is amplitude here? Maximum displacement from mean position. So this is what you can say which amplitude A. Again, wait and see what you can say. This is what amplitude A. Now again, which you can say amplitude A. This is my dear. Again, what you can say? Amplitude A. So as a plane progressive wave, progress, there is no change in amplitude, speed of wave and frequency. There is no change in what? Amplitude. Better note down here. This one, everyone, in note. Students, everyone, note down in note, my dear. Yes, as I said, what is amplitude? Maximum displacement from mean position, my dear. You can write over there maximum displacement from mean position. Okay, so note down with me, everyone. As the plane progressive wave, student, as the beta plane, as the plane progressive wave, as the plane progressive wave progress, as the plane progressive wave progress, progress, there is no change in, there is no change in, there is no change in amplitude, beta A is amplitude, amplitude, speed, speed of wave and frequency, and beta frequency, right? This is the point which you can keep in your mind. Now, bacha, I can see we have another kinds of behavior. So this is what PPW. What's the main point for PPW? You can see as the plane progressive wave, there is no change in what amplitude, speed of wave, and what frequency. Now, bacha, I can see the next is what damped wave. What my dear? This is DAMPED, damped wave. Okay. So the, what you can see in this wave here, no, but there is loss of energy. Sir, longitudinal wave can pass through solids also. Uh, I can say, but for solids, they can have transverse and longitudinal wave. You can tell, bacha. Yes, beta. I forgot to tell, beta. This thing, beta, Shagar. For solids, beta. You can write down in notes, bacha. In everyone write down in notes, students. Everyone write down in note, bacha. Okay. What my dear? They can have, beta. This is point for solids. This is beta point for solids. They can have they they can have transverse transverse and longitudinal waves. Beta solids, beta you can take for both, beta is the longitudinal as well as transverse wave. Okay, now beta, we have to continue with everyone here. Yeah. So what is the damped wave? What is the damped wave? Okay, here you can see what is the energy dissipation. This is what, my dear, you can take in consideration energy dissipation. Okay, but the next and last for types of wave. What, my dear? This is simple harmonic wave. This is what, my dear? Simple. Don't be scared, everyone. Don't be. There's example student. Don't be scared, anyone yet, right? Because I'll give. I'll if required some point about SHM, so I'll teach concept. I'll teach theory point also, so that you can feel comfortable to understand wave motion. So with a simple harmonic motion. This is what, my dear? Simple harmonic motion. Okay, student, God bless you for your reaction. Yes, bacha ji. For simple harmonic motion, bacha, what you can say? But you know, in simple harmonic motion, each particle of media performing simple harmonic motion. Beta, in simple harmonic motion, or you can also say simple harmonic wave, basically, it's more clear for us because we are learning wave now. Simple harmonic wave. What, my dear? Simple harmonic wave, right? SHW, you can write in short. So, beta, for simple harmonic wave here, just keep in mind what is the thing, bacha party. You can just first understand what with the help of diagram. Student, first you have to understand what with the help of diagram. Okay, but I take your consideration. As the same example, hold SS holded one end of the string in I can say in him hand, right? So once he apply energy, so particle beta what propagate and beta we can observe this kind of what formation of pulses take place. Formation of pulses takes place, right? So, no, but every particle, because now I'm considering situation over here. If t is equals to 0, what, my dear? T is equals to 0. So there is no displacement at all. There is no displacement at all. So what it means, the particle is performing SHM. Particle is performing SHM. And beta, for this condition, you have to also use what is the equation of SHM wave. What is the equation of SHM wave? So what will tell you? By H equals to A sine omega t. Beta, this is what I'm writing here directly. Otherwise, this all are, I can say, proof of simple harmonic motion. So I'll not go for too much proof, but I'll try to just give a result directly from SHM because SHM result is literally highly important to understand wave, right, my dear? Okay. So I can say simple harmonic wave, it I just take in consideration in simple harmonic wave, each particle performing what? Simple harmonic motion. In simple harmonic wave, what you can say each particle is performing simple harmonic motion. Okay. I hope all of you have taken it and understand what is simple harmonic wave and what is a simple harmonic wave. Okay. Now onward, which I can see theory point here finished. Now little derivation and we'll do numerical. Yes, beta. Have a look over here. So again, Vacha, I can say general equation. Put everyone heading with me only. This is what, my dear. What is A and omega? A beta amplitude. Yes, beta. Good beta. Shubham. Bacha, A beta amplitude, my dear. And omega is what? Angular frequency. Shubhang beta. A is amplitude beta. Because this is what particle is performing beta accession. So you can write this is amplitude. Particle is performing beta accession. So this is what, my dear? You can say amplitude. And omega is angular frequency. Omega students angular frequency. I hope you got it, Shubhang. Uh, just I'm a student. Okay, fine. Now with Chapati, have a look next year. Subhang, your doubt clear? Subhang, beta, your doubt clear, my dear? Subhang, your doubt clear? Okay. Okay. Good, good, good. Good, beta. No, you can ask with Chapati. Uh, in live session, yeah, I can see all of you, those who join now, literally doing very good job now. Very good job, beta. Good, 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 good. Good, Subhang, beta ji. Now, beta, put the heading, everyone, with me only. Heading, beta. Now onwards, no need to write. Now onwards, no need to write. I'll give time to write. Beta, just listen here, each and every step. Literally, beta, this is a highly important. So no need to write here, everyone. Stop your writing and be concentrate on class only, beta. So this is what, my dear. This is general equation of. Don't write any student. Listen me carefully, class. General equation of. General equation of traveling wave. What, my dear? General equation of traveling wave. Okay, fine. Beta, already you understand. In a wave, simple harmonic wave, each and every particle is what? Performing SHM. Is what? Performing SHM. So, beta, just take in consideration. At any time can be anything. Time can be anything. So, this is you observe kinds of wave. Right. So you wanted to analyze the situation. So you can take with consideration. This is what particle is here basically. Right. T0 and X0 beta. You can take in particle coming like this only. So beta in time T, particle this must travel in what you can say bidirections and students from here to here. You can take this is the distance traveled by particle. You can say along x-axis. This must travel. These all things which I have drawn for time t only. This is a situation you can take for consideration as I said previously. That is time zero. So particle is here. There is no displacement at all. What I wrote already. This is x and t. Both what I can say which are here I'm discussing for any function or any value of time t. Now students you can take this is what v is the velocity. V is the what, my dear? Velocity of wave. V is what, my dear? Velocity of wave. Okay, fine. So, as I said previously, uh, y is equals to a sine omega t. For that case, I can say I wanted to show this here, this diagram, this equation. But here, initially, I didn't consider what is the initial phase students for this case, I didn't consider what is the students, you can say initial phase, right? But here, students, I'm going to just see this here I'm considering for entire derivation, initial phase of the particle, initial phase of the particle. So here, student, I'm writing y is equals to a sine omega t plus phi. I'll explain everything with you. So A is beta what? Amplitude. Omega is what? Angular frequency. T is what? Time. And phi is what, my dear? Phi is nothing but you can say this is initial phase. This is what, my dear? Initial phase. Right. Okay. So we can talk about I can say here for y as a function of x comma t. Student, here I'm going to the procedure because this is what particles travel in time t x horizontal and by beta what you can say vertical. So here you can write, my dear, this is y as a function of x comma t. Y as a what function of x comma t? What? Student, this is a sine of omega into beta. This is what you can take t minus x by v plus phi. But here you can ask one thing. Beta, here you can ask one thing. Sir, why, sir, what is phi? Phi beta, initial phase. Initial phase beta mean, I mean to say, Shivang, you can say particle initially traveled some angle, right? So how this is, I'll tell you beta very soon, beta. Beta 5, you can understand easily if I'll give numerical based on this. So wait beta for coming 10 to 15 minutes, right? Maximum 10 minutes. Then you can easily understand what is the initial phase. Give me some time, beta. Okay, correct. Good, Shubham, beta. I can see you are looking beta today very active here. I can say Sagar, SS, I can say finally. These two people sleeping mode. You are active, bacha. I'm proud of you, beta. I can say first time you are beta joining live session, but your performance literally beta. Very good. Okay. So beta, have it okay. Y is what? A function of x comma t. A sine omega t minus x by v plus I. You can beta. You can ask, sir, why root x by x y v? Beta take. I think Suma. In everyone take in consideration. Beta say this is your home location. This is, you can say, your home location, right? Now, which I say, this is, you can take a destination point. Okay. So now, which just take in consideration distance between your home location and destination. That is what 6 kilometer. Take this example. This is what dear you can take 6 kilometer. Okay, beta, I can see 6 kilometer is what basically distance between home location to destination. Got it now? Beta, I can see in this 6 kilometer you already traveled 2 kilometer. What is remaining we have? What is remaining we have? 4 kilometer only. What you can say? 4 kilometer only. So this is initial time is t. So beta, I wrote here again time only. How much you traveled? That is x. And what's the speed of the wave? That is v. So time got decreases. So you can write directly a sine omega t minus x by v. A sine omega t minus x by v. Just beta open the bracket. Omega beta multiply in all. Omega beta you have to first multiply by t, then omega you have to multiply beta. I can say x. So here you can write, my dear, y as a function of x comma t. This is students a sine. Listen carefully. Don't write anyone. Don't write anyone. Listen me carefully, beta. That is very highly required. So omega t minus beta omega x by v plus you can say phi plus you can say phi. Now, students, there is one more interesting point here which I want to discuss. Students, just now I finished initial general point of physics. Basically, you can say frequency. So, beta, omega is nothing but what you can write. Sir is speed of wave. V is the speed of wave. Yes, beta. V is the speed of wave. Yes, beta. V is the speed of wave. Uh-huh. So omega beta, what you can say? Omega is what? Just now, omega be finished. You can write it there. Omega is what? 2 pi by. Now, Sagar look like active only. Just now, I can say omega is beta, what you can say? 2 pi by t. So 1 by time period, just now I said here, it's the frequency. So here you can also write, my dear. Here you can also write, my dear. This is what? Omega, which is equals to 2 pi f. You can also write what? Omega is equals to 2 pi f. Beta, just divide both of the sides here. I wanted to do this mathematics in the next page. I'll give time to write beta, Subhang, Sagar, and everyone. Just save the live system. First, I'll finish the derivation. Then I'll give time to write here. Just be concentrate. Beta, just now we finish here. Omega is nothing but 2 pi by time period. And we know 1 by time period, you can say frequencies. So you can write, my dear, this is omega, which is equals to 2 pi f. Omega is what, my dear? This is what you can say 2 pi f. Beta, divide both sides by v. So this is, students, you can say omega by v is equals to 2 pi beta and f by v. Yeah, just now we finished it. Beta, this I proved here this result. V is equals to uh, lambda f. V is equals to lambda f. So this is what you can say, bacha party. V upon f is equals to lambda. But this is what you can say, f upon v is what you can write, f upon v is equals to 1 by lambda. So beta, I'll use beta this result over here only. So this is what, my dear, you can say basically omega by v 2 pi by lambda. It's nothing here. It's k is equals to k. You know, beta, they asked multiple times about it. Correct, Sagar beta. Correct, beta. Yes, yes. Very good. All of you look like active. I'm feeling proud on all you, beta. Beta, I'm feeling proud on all of you. Okay, now beta, omega by v 2 pi by lambda is equals to k by 7. No, this k is what known as, my dear? This k is known as wave number. This k is what, my dear? Known as wave number. Okay, so now beta, I'll use here this result here. What I proved here previously is y is equals to a sine omega t minus beta what? Omega f by v. Omega by v into x plus 5. Omega by v beta, what we can say? This is x near. Omega by v is what? Beta k only. So we can write beta. This is what general equation of beta traveling wave. Y is equals to what, my dear? A sine omega t minus kx plus 5. What is, student? Y is equals to a sine omega t minus kx plus 5. Okay, so beta, this is real result here, which you can keep in your mind. And now onwards, we will use multiple time. Now onwards, beta, we will use what? Multiple time, beta. Now, just after 2 or 3 minutes, beta, I'm going to solve J advanced 2025. Just imagine how this is important, beta, Sagar, Shubham, SS, or those students who present currently in the class like during live seminar is one beta literally highly important here. That's why in the I totally believe, my dear student, uh, go through K. K is beta Shubham wave number, as I say. K is what, beta party? Wave number. Just imagine here. Just now, beta, you are solving the questions only. Just now, just I thought only concept. I didn't too much numerical. It has J Advanced 2025 asked question based on this only. This much. There is a little one point, one more point, which I'll tell you very soon. So now, beta, till now, I'm telling no one writes. No one write, beta. I'll give time to write. I'll give, then you can write, beta, party. Okay. So, beta, I'm going to write here. I can say in a one box this formula. Definitely, beta, each and everyone, you will get this formula forever. Either you are going for NEET, you are going for JEE, or any competitive examinations. Be remember Vox formula of BK Sir. Be remember Vox formula of BK Sir will help you. You will get multiple help here. Definitely will get benefit. So this is beta first equation here, which I wanted to write. This is general equation of traveling wave. What, my dear? Y is equals to a sine omega t minus kx plus 5. This is the first beta g. Second beta, just now you know, omega you can write what? 2 pi by g. So you can also say bacha, y is equals to a sine. Beta, this thing here, I'm just taking beta. Omega, I'm using beta two tools over here. Omega is what? 2 pi by capital T, and beta k is equals to 2 pi by lambda. Beta, this thing here, you have to put beta in these equations. In this equation, beta party. Okay, beta. Very good, beta. Yes, yes. Okay. So now beta party. Beta, this 2 pi beta, I'm just taking common. This 2 pi beta, I'm taking common here. You can say small t by capital T. Minus beta party. This is what? X upon lambda. 5, you can take its own ways, right? 5. Then beta party, third question, sir. Third equation, what you can write? Beta, you can also write here y is equals to first equation beta, which I said omega of t minus x by b. Y is equals to a sine t minus x by v. Right, Vachaji? Okay. Beta, there is a few points here which you can keep in your mind, everyone. Beta, first note down everyone here till now. Beta, first I want you to show this derivation. Beta, from here, you have to note down each and every one. Then beta ji, I'll start here further.
Yes, beta. Note down with me, everyone. First, you will finish because here this is a class only for grooming in your sense subject knowledge. Do everyone. If you finish here, just write in chat box, sir. Yes, I have done. Change the page. Then beta, I'll change the slide here. Slide is, I mean to say page. Write down each and everything. Be concentrate on class. Okay, no down. Don't worry. Beta, note down here. Don't worry. No need to hurry here. Okay. I hope all of you done. If you have done bacha, then say, then write in chat box. I'll change the page. Swang notion means, what does it mean? Till now I didn't write. Till now, beta, you didn't write Swang. Okay. Sagar said yes. So should I change the page? Hello, woman. Okay, should I change the slide? So now I finished. Okay, okay, fine. Should I change the slide, my dear? Students, should I change the slide? Okay, good. Good, 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 good. Beta. Beta, note down this page. Okay, good Subham beta. Once you finish my idea, then just write in chat box. Okay, woman, it's fine, beta. You have to first concentrate, beta, your exam. Once you will finish, beta, then this class is regularly going on. Yes, beta. No, beta. First, you have to focus, beta, on your exam only. Woman, my dear, first you have to focus 10th, 12th class board, beta, right? You will finish, then you can come back. Woman, from where are you basically? Which state? Okay, I hope all of you written students. Should I change the page? Quickly just revert me. Oh, very good. Students, should I change the page? I hope all of you done. I hope all of you done writing work. Okay, fine. Yes, why not? Is it fine now? Sagar, yes. I'll talk you tomorrow in the class too, or phone calls, not here in live session. Students, should I change the slide? Okay, for I can see in written board, like say paper of your exam or board, you will get time. Then you can come and you can learn something. What is the definition of K? K is a bit of something you can say wave number only, right? So there is not a such particular definitions I can tell about wave. I hope done. Done everyone? Okay, beta, this is last year. So this is a point here. I can tell you what's a party. Everyone, we remember these three questions. Student, 100% you will get this question. 100% you will get problem based on this. So be remember and stay tuned. Anytime you can watch the video. Search yes, Subham. Okay, now I hope all of you done till here. So now onward, bacha, just I wanted to convey few points here. Few points, bacha, party. Because bacha, I can see amplitude as I said. Yes, beta. There is a few points, bacha. Just note down in note so that we can do the questions of J Advanced 2025. Beta, note here only, bacha. In note. This is what note, bacha, party. Everyone, beta, note down with me. Wave reflects back. Student, wave reflect back from denser medium, from denser medium, then there is change of phase. Then there is change of then there is change of phase, then there is what, my dear? Change of phase, which is equals to pi, which is equals to pi. Okay, but everyone here, note down, students, with me. Means this is for you only here. Phase, because this is question asked by Subhang basically, right? This here, note down everyone definition of phase, right? What is the phase? Beta, phase defines. Note down with me, everyone. Already I said what's a phase. Phase defines the position. Phase defines the position, bracket, bracket, in terms of distance. Phase, 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 phase defines the position in terms of distance from mean position. Phase defines the position in terms of distance from mean position, bracket close, and velocity of particle, and velocity of particle oscillating beta, velocity of particle oscillating beta g, velocity of particle is oscillating under the influence of wave. Velocity of particle is what? Oscillating under the influence of wave. Velocity of particle influencing under influences. Okay, fine. Now bacha party, I can say there is few things beta which you can understand. I can say about phase. One question I'm doing beta because of Subhang. Subhang asked about the phase. But I can take in consideration as an example. You can understand what is the phase. It's literally beta. It will help you a lot to understand what is the phase. Bacha, you can take beta. Let us suppose any wave pulses like this. Okay. So beta, for this condition, let us, I'm calling this point is 1, beta this point 2, this is 1, this is 2, this is 3, this is 4, this is 5. 1 2 3 4 5, right, my dear? Okay, so now you can understand phase, how the phase. So the oscillations of particle 1 and 4, 1 and 4, what we can say about it? Oscillation of particle 1 and 4 are in phase, right? Beta oscillations, just you can understand, oscillation of particle 1 and 4 are in phase, right? But which I can say oscillation of particle 1 and 2 are not in phase. 1 and 2 are not in phase. Beta, you can understand what is the phase. 1 and 4, 1 and 4 in phase, 1 and 2 not in phase, 3 and 5 in phase, 3 and 5 in phase. Beta, again you can say 4 and 5, 4 and 5 not in phase, out of phase, right? So this is a way to understand phase. This is a way to understand phase, my dear. Okay, have a look at numerical based on this. What is J advanced beta 2025 year? All of you ready for questions? Write in chat box, yes, no, show your reaction. All of you ready for questions? Write in chat box and show your reaction, everyone. Write your interest. All of you enjoying session of physics point. Then show your reaction in okay, till now I didn't get any reaction from your side. It means all of you not ready for the question. I wanted to beta start question based on this. All of you ready for the question? All of you ready for? Okay, I got reaction. Yes. Okay, Shubhang, I got reaction. Okay, Sagar, yes, yes, yes. Okay, I can say SS is not available here. Okay, two candidate. Okay, bacha. Now I'm going to solve the questions here. Now beta ji, I'm going to solve question here. What I can say, JEE advanced. Just imagine beta, Shubhang, Sagar, beta, how JEE asking questions, bacha. No, that's not telling. Theory highly required. Theory beta ji highly required here. So this is what, my dear, JEE beta advanced 2025. What my dear? JEE Advanced 2025. What's the question? Literally, beta, I'll not give a entire definition, entire question, bacha, right? Because time is very less. You will write questionnaire, then will take at least 10 minutes. So I'll not do. I'm giving you bacha because I have a questions, data of the questions. What's the questionnaire? Just one time I'll read. Consider a system of three connected strings S1, S2 and S3. Okay, so beta, I know there is diagram already beta given in the questions. Student diagram already given, so beta I'm drawing same diagram. Student, I'm drawing same diagram. Student, I'm drawing same diagram which is mentioned the questions. Uh, in fact, beta, there is already given in the diagram itself. It's a ball. Okay, now I got a reward from your side, beta. SS, where you gone, beta? Is there any network issue? Okay, yes, beta. This is wall, right? Now, beta, I have taken string here, normal string. But what's there are three. What says there are three strings? So, beta, I wanted to show here. You can take, beta, this string, this blue color here. Maybe it's black for you. But this string beta I'm considering it's S1 beta from here to here. There this is the next one here. So I'm considering this green color. Maybe green looking you. Okay. Beta this is a green color. This is a different string. Beta J, this is a student green color. This is a different string. Okay, now I can say I have one more. So this is literally I'll say black color. Okay, so you can say bacha, consider a system of three connected string. Consider a system of what, my dear? Three connected string. Okay, beta, there are three strings. Literally, it's a very good question here. It's a very good question. You will enjoy these questions. Yes, this is my promise. Now, beta. So now, students, I'm calling. This is what, my dear? S1. This is what? S2. This is what? S3. Okay. I can say. Why you wrote no, sir, beta? I can say SS. I didn't get your concern. Okay, beta, consider a system of there are three strings S1, S2 and S3 with uniform linear mass density. But I know, beta, in string, I can say in an LM, we were not considering what is the masses. But here mass is given, bacha. So string masses we are not representing by M. It's a mu. It's what? Mu. So beta mass is mentioned here. Beta for this condition you can take string one student. This is, my dear, mu kilogram per meter. This is beta G 4 mu kilogram per meter. Yes, beta. This is 4 mu kilogram per meter. This is beta G 16 mu kilogram per meter. Yes, beta. This is the condition here. Now, beta, I can say S1 is what? Mu. Means this is the mass per unit length. Bacha party. I hope all of you know linear mass density. This is bacha ji 4 mu. This is what? 16 mu. I wanted to highlight here. This is 4. This is 4 mu, bacha. Okay, fine. Then what's in the questions here? I can say respectively as shown in the figure. S1, S2 and S3 are connected at a point P. S1 and S2. Okay, they mention also about a point here. So, student, this point is name is mentioned. This is P. This point beta P means S1 to S2 connected to what? At point P. Beta S2 to S3. S2 to S3 beta. This point is what? Basically Q. S2 to S3 beta what? You can say point Q. This is the condition. Okay, fine. This is everything beta finished. What's mentioned in the question? Little one more point. A wave generator O. Wave generator O. You can see beta something. There is beta kind of arrangement here. Just you can understand like this. There is a wave generator. Okay, this is the instrument which is responsible to generate the wave. This is the I can say instrument to responsible to generate the wave. Let us suppose this point is mentioned, bacha. This is point O. Beta for direction, what they mentioned today. This is X. This is X. This is Y. So normal beta, we are considering same directions only. Okay, observe wave generator O is connected to free end of S1. To free end of S1. The wave from generator is represented by. So beta, what's in the questions? They mentioned what is the wave equations. This is by is equals to by naught cos of omega t minus kx. This is a bit of equations which I'm giving you till now. Just I'm completing question statement only. Y is equals to y naught cos omega t minus kx. Okay. Now, bacha party, we have to answer the question. Everyone, just finish this data here. Everyone, finish data with me. Everyone, finish this data here. Everyone, all of you finish data with just now. Okay, if you finish data here, so but I wanted to write here. I can say options. Options I'll write here. So this is beta options one. What, just note down with me, everyone. When the wave student, when the wave reflects, when the wave reflects from P for the first time, the reflected wave is represented by, reflected wave is represented by is equals to y is equals to beta alpha 1. No need to worry, alpha 1, it's a constant. Alpha 1 y naught cos of omega t plus kx plus pi centimeter, where alpha 1 is positive constant. Where beta, what you can say, alpha 1 is positive constant with party. Okay, this option is finished. Now student, I'm going to write here options number seconds. When the wave transmits, through P for the first time, the the transmitted wave is the transmitted wave is represented by y is equals to alpha 2 y naught cos of omega t minus kx in what beta ji? Centimeter. Alpha 2 is what? Alpha 2 is beta what? You can see remains positive constants. Beta options number C. When the wave reflects from Q, when the wave reflects from Q for from Q for the first time the reflected wave is represented by the reflected wave is represented by y is equals to alpha 3, this is y naught cos of beta omega t minus kx, omega t minus kx plus pi. But I'll repeat here, y is equals to, my dear, alpha 3 y naught cos my omega t minus kx plus pi, minus kx plus pi, right? Beta last option. I hope all, sir, can you solve? हाँ wait here, without option, because answer inside the option only. So first beta I'll write entire options here, then I'll solve the questions. I hope all of you written till now. I wanted to write one more options. Okay. So beta, this is options last for these questions. Yes beta. When the wave student when the wave transmits through Q for the first time, the transmitted wave is represented by by is equals to alpha 4 cos of omega t minus 4 kx beta in centimeter, where alpha 4 is constant, where alpha 4 is what? Constant. Okay, so I hope all of you written. So now beta I'm going to start solution of these questions here. Now beta ji I'm going to start solution of these questions here. Okay, so beta just have a look here. We'll go through option first. It's not tough questions, literally no, because just I wrote this much only, but this much length of the question basically, right? So for this condition, just keep patience in the advanced paper here. Just be maintain patience. Literally paper is not much tough. Okay, so beta have a look here the questions. There is oscillator which is responsible to generate the wave. This length is what you can say S1, which is equals to mass is mentioned mu kilogram per meter beta. P1 to P to Q, it's what existing is 2, mass is 4 mu kilogram per meter. Q to beta I can say till wall of the surface is, this is what 16 kilogram per meter. But one more thing here I wanted to tell you everyone. Bacha ji, you can note down a note. Not for these questions, just you can note down general note bacha ji. Beta note down everyone general notes there. Okay, beta I can say, if note down with me everyone, if beta point number 1, if t and x have a same sign, student, if t and x have a same sign, means you can say t and x both are positive or both are negative. If t and x have beta ji, you can say same sign. If t and x have a what beta, you can say same sign, then beta j, velocity of wave in what, my dear? Velocity of direction of wave, you can write. Then velocity of direction of wave. Then I didn't write velocity. Then velocity I'll write here complete. If t and x have a same sign, then velocity of direction of wave is in negative x direction. Negative बच्चा जी x direction. That note number 2 everyone. If t and x have different sign means you can say either t is positive, x is negative, t is positive. So beta, if t and x have a different sign, if t and x have a different sign, beta ji, if t and x have a different sign, then direction of velocity of wave, velocity of wave is in, my dear, positive x-axis. Positive beta, what you can say, x-axis. So literally beta, which I gave, this is the highly required beta j, highly required beta, and very very important here, very very important bacha party. Okay, fine. So I hope all of you done these points. Now we are ready to solve this question. Student, can I start the solution of this question? Student, can I start solution of these questions? All of you ready? All of you ready? Then just show your reaction. If all of you ready are, then show reaction bacha party everyone. Okay, Sagar, I got reaction. I got very good. Now bacha, have a look at these questions. Beta, one more point. Beta, which I said Sagar beta somewhere. Yes beta, this point. wave reflects from denser medium. Denser medium beta, I mean to say, you can say that is beta fixed medium or a stronger medium, right? Fixed medium beta, then there is a change of, if any wave reflect only, transmission not allowed. If any wave, let us suppose this is the wave, I can say my hand is here. So beta, if this wave just I can say hit my hand and come back again, so this is what reflection. This is what reflection. So you can see this phase there is what change of phase, how much pi. Initial phase is what 0, but if this wave finally hits my hand and come back bacha, then what you can say my dear, this is nothing but basically what change of phase is pi. So this thing beta we can apply over here. So have a look beta, just everyone read here option number first. Everyone read beta option number first. When the wave reflects from P from here, means wave reflects from P, correct only. For first time beta, then wave is represented by, so beta wave is coming back here. So we remember everyone, sir, this is what cos of beta, what we can say, cos beta, tell me everyone here, cos of beta, correct only no, omega t, change of phase pi, change of phase pi, because this is what minus x here, so wave going in this direction. Beta minus x means what you can say, wave beta in this direction here. Just keep in your mind what's about it, right? So beta this is in a beta direction, but particle going back here. Just now I said, if t and x have a same sign, if t and x have a same sign, bacha, then beta what we can say, particle motion in negative x-axis. So you can say bacha body. Initially what negative over there, particle again going back. So negative becomes positive. Right, bacha party? So this is condition here. I can say then option first is correct. Then beta what you can say, option first is correct. All of you agree? All of you agree for this question, answer of questions? All of you agree for this question? Option first beta solution. All of you agree with solution? All of you got the solution of this question? Options A, why it is correct? Why this is correct? Just show your reaction and write in chat box yes or no. Yes or no? Okay, fine. Option A is correct. Now beta, have a look here. I can say next questions. What's beta next option says? When the wave transmits through P. Wave transmits through P. Okay. For the first time, the transmitted wave is represented by. Transmitted wave is represented by. How possible was that party? Not near. Beta, not just now we finish here. Beta, I can say K is what, bacha party? Beta, I know this question there is a little twist. In this question, bacha party, there is a little twist. How? I'll tell you. Come beta the points. Just attention here only, everyone. So I can say in beta solutions. What you can write? Just now we finished here. Omega by V. It's nothing but it's K. Omega by V, it's nothing but you can say bacha party K. Yeah, velocity beta of wave, you don't know. Velocity of beta. Velocity of bacha, you don't know what is the velocity of a stationary wave. But now I'm telling bacha party. Velocity of a stationary wave, bacha, you can write this is what T by mu. I'll prove this result very soon. Beta, I'll prove this result very soon, just for sake of time. Keep in your mind. What is the velocity of beta? I can say. Then what I can say, this is what? Root of T by mu, bacha. So beta, this result you can feed over there. Then what you can say? You can say, bacha ji, sir, this is what? Omega. What is initial mu, bacha? Mu only. Beta, this is what? You can say T, bacha party. And this is what? You can say mu. And this is what? K. So K I can write, my dear, over here. K is what? Directly proportional to mu. K is what? Directly proportional to root of mu. Because you know better, tension in a string. Everyone knows bacha, tension in a string must should be constant. Tension in a string must should be constant, bacha. So K beta what you can say? Root of mu. K bacha what we can say? Root of mu, bacha party. So have a look here for this question. What says? Option number second beta ji. When the wave transmitted through P for the first time, the transmitted wave is represented by, this is what they said, as usual what? K into x. Beta what say that k into x bacha party, and k is nothing but it's what? Root of mu. Beta what I can say, k is nothing bacha. K already I proved. Root of mu bacha. So what you can say, options Bombay is incorrect. Options Bombay is incorrect. Now beta have a look here, option number C. Have a look everyone, option number C. So what say bacha, option number C here? When the wave reflects, when the wave reflects from Q for the first time, the reflected wave, beta what you can say, the reflected wave is represented by reflected wave here. Beta particle coming back from here. Bacha ji, particle is coming back from here, bacha. And what's a reflected wave? So, bacha, you can say, beta for reflection, there is what? Change of phase is pi. Beta ji, for reflection, what you can say, change of phase is pi basically. So, and one more thing, one more I can say, things you can take in consideration. Students, you can take in consideration, that is one more thing, right? So what bacha party you can say for this condition? I hope, how many are just currently watching here? Just say yes or no here, because I'm not getting proper reply from your side. Yes. Or it's a tough here. No. It's not a tough questions at all here. Literally I'm telling you. Betaji, this is not a tough questions here. Why not responding even here from all of you? Why all of you look like sleepy only here? Tell me, bacha party. Why all of you sleeping here? Okay, Shubham. Okay. Good. Student, good afternoon here. Someone new students. Okay. So beta again here. This is what option C is incorrect. Bacha what you can say, option C is bacha party incorrect here. So now bacha have a look last one, my dear. That is what? When the wave transmits through Q. Keep in your mind. Because I have to change their page left right, but you have a notes already have written. So just watch your what I'm telling you. When the wave transmits through Q for the first time, the transmitted wave is represented by transmitted wave. Okay, correct on it, beta. Why? Because no bacha body. What is the distance over there, bacha body? Everyone see here, K is what? Root of mu. K is what, bacha party? Root of mu. So beta, this is what is there? This one, bacha party. How much you can say? 16 mu. Beta, what we can say? This is what? 16 mu, bacha party. So you can say K under root beta what? Tell me. K what under root beta? 4 of mu here. 16. So beta, this is correct here. Alpha 4 cos of omega t minus kx plus, this is what? In centimeter here. So this is options D is correct. Options D is correct. Options D is correct. Right? Okay, I hope you got it here, everyone. Yes, beta. So I can say there are, it's beta multiple correct, one more than answer, bacha students. So options A and options D beta, that is what correct only. Right? So bacha party, this is a literally, maybe I took this is the toughest questions one, but don't worry, I'm giving you beta next question that is easy. Now students, I'm giving you a next question that is what literally easy, bacha party. Okay, just beta answer me everyone for the questions. Okay, one beta just note a note here everyone before answering the questions. Yes. Then I'll do a little easy question, bacha, so that you can understand. Sir, when will you? Beta, just 1:30 beta. I have remaining beta 11 minutes only beta. Sagar beta only beta. I have 11 minutes only beta. Okay, just note down everyone. If beta velocity of wave formula beta. This is velocity of wave. It's nothing, my dear. Beta, take in mod coefficient of t. Student, coefficient of t. Now I'm taking fundamental numerical here. Coefficient of t by beta g coefficient of x. Coefficient of t beta, what I can say, coefficient of x beta. Now you have note down question with me everyone and answer me beta every question quickly. It's a fundamental numerical. You can answer me my dear. Okay, bacha buddy. So this is what by is equals to a sine omega t minus kx. Right. So beta, you just tell, is this, sir, this type of question is in worksheet. Uh, this type of question or previously, which you solved advanced type of questions. If you are talking with us Swang about this question, bacha, or I can say this question. Which question? Okay. Now, beta, this answer. Comment, beta. Comment. Given equation belongs to this type, this type, S, you will get beta, 100%, S beta, yes, this, no, beta, this formula beta Shubham, I can say beta, I can't say how many times, multiple times they asked, you can just watch just little, just give some time, bacha, but maybe today I didn't, I can say too much numerical, tomorrow will do too much numerical, bacha, party, so keep in your mind. What's answer bacha? Comment on given equation belongs to, comment on given equation belongs to uh, wave, traveling wave or not. Comment on given equation belongs to traveling wave or not. Just answer me bacha. Comment on given equation belongs to traveling wave or not. Just answer me quickly beta. Answer me beta quickly. It answer just now we proved. Just now we proved here box only. Why just taking more time beta? Answering the question here? Yes, you can say correct only. Y is equals to a sin omega t minus kx. Yes, then why taking more time beta? Student, why taking more time bacha? Answer is yes only. Yes, it is a traveling wave. In solution, you can write yes, it is. Yes, it is traveling wave. Simple. Next picture, ji. Next picture, ji. Y is equals to 8. You take. Just I'm taking any random data, which just keep in your mind. 2 pi f into t. 2 pi f into t plus 2 pi by lambda into x. Question that you will see. Comment on is it traveling wave or not. Comment on is it traveling wave or not. Comment on is it traveling wave or not, and what is the propagation of direction of wave, and what is the propagation of direction of wave. But you have just answer me two things. Comment on is it traveling wave or not, and next student, comment on direction of propagation of wave. Comment on direction of propagation of wave. Anyone? Okay, fine. Now, Richa, I'm going to solve these questions, my dear. Okay, minus, okay, Shivang, minus x direction. Correct, Shivang beta. Just very good. I'm beta proud of you, bacha buddy. So now, bacha, you can say here for this condition, y is equals to this. Beta, just take here 2 pi f common. Beta, what you can take 2 pi f bacha common here. So this is what, my dear. You can write y is equals to a. This is what which I can see. Which are cos as usual. This is what, my dear. 2 pi which party. This is t plus beta, what you can say, x upon lambda into f. Right now? Okay, correct. Sagar, yes. Correct, beta, correct, beta. Both of you are belongs to traveling way. Correct. Very good. Correct, bacha party. So with S, you can say S, it is a traveling wave which is propagating what? Negative x direction. Beta, somewhere you can also beta write here these equations by E is equals to A sin bacha 2 pi f t plus x by lambda into f. Okay, good, yeah. Beta, next question. Move ahead. I'll do beta little easy question here. It's a fundamental. Already I said. Beta the next question बच्चा party. Question remains in बच्चा. Comment on beta जी direction uh, of propagation of wave and beta is it traveling wave or not? Yes. So everyone have look at the question, students. Y is equals to a e to the power beta 2 pi by capital T into small t minus beta, everything in power here, just keep it in mind. This is 2 pi by lambda into x. I can repeat here once, everyone. Student, y is equals to a e to the power 2 pi by capital T into small t minus 2 pi by lambda into x minus 2 pi by lambda into x. Question remains same, student. Just you have to comment. Given equation belongs to is it traveling wave and what is the propagation of directions of wave and what is the propagation of direction of wave. Anyone from all of you answer me this question? Okay, beta. Very good. Positive x-axis. Correct, beta. Very good here. Yes, literally here, all of you look like very active in live session here. Very good. Literally, you are gaining knowledge in the physics. Beta in solution here, I can write beta. Just beta, I'm taking common here, 2 pi by 3. Right, beta. So this is a e to the power of students 2 pi by capital T into beta small t minus x by lambda into t. Right, students? So just you can take in consideration. Beta, one more last question for today class. Yes, beta, time going to finish. I have only 2 minutes. So this is the last question, or you can say second last question of today class. Y is equals to student A sine omega square t square minus k square x. Questions remain same, bacha. You can take in consideration. Comment on directions of wave and is it belongs to traveling wave or not. Belongs to traveling wave. Okay, fine. Anyone from all of you answer me these questions, my dear? All of you welcome at Physics Point in live session. Okay, just answer me, anyone from all of you. Okay, fine. Student, God bless you, everyone here, for your answer. Your answer correct, student. Correct, students. Okay. So beta here you can write here. This is a beta. You know it's what a square minus b square, my dear. A square minus b square. So here you can write beta. This is omega t minus kx into omega t plus kx. So beta, this is what we can see. Answer literally no one gave correct answer here. Beta, this is what you can see, non-traveling. Yes, student, correct answer. This is correct here. This is not traveling wave. This is belongs to No traveling wave. No traveling wave beta. This is belongs to what? No traveling wave. Yes, bacha. Don't worry, bacha. Just keep in your mind, beta points. Don't worry, yaar. Everyone. Very good, bacha party. I'm looking very happy to see yaar, everyone in the live session and how all of you performing beta. Yes. I'm very happy to see beta ji. Okay, so now beta, what's the assignment for today, which I wanted to tell you, bacha. I can say I don't have things, but I can give you beta assignment for tomorrow. Beta, you have to answer me, beta, your answer assignment on WhatsApp. Already I gave you my WhatsApp number. Write your name and WhatsApp live stream timing. Beta, seen on WhatsApp. Solution of the questions. Again, I'm repeating, bacha. I'm giving you assignment. You have to just answer me your question on WhatsApp with your name and live stream timing. Okay. So, beta, just note down question, everyone. A wave traveling along positive. A wave traveling on a wave traveling along positive x-axis. Positive x-axis beta. This is question number 1. Velocity of wave beta you can take, this is 2 meter per second. 2 meter per second at displacement. At displacement x is equals to 0. X is equals to 0. Beta you can take beta. It's a Roorkee question, yaar. It's a IIT Roorkee question, bacha. Y is equals to twice of 1 plus g square. Beta, what you can see, y is equals to 2 by 1 plus g square. Find equation of wave. Student, what you need to find? Find equation of wave. Find equation of wave. And beta, remaining this beta, everyone revise your class notes only. I'll not give beta much numerical and much assignment. Just I taught literally today fundamental topic of waves. If anyone joined newly, so go and watch beta entire syllabus. Right, students? And tomorrow I'll see everyone. Now, student, I'm going to stop live session. All the very best. God bless you.